Have you ever thought about why copper wires are used in electric circuits, or why sulfur is brittle and doesn't shine? That's because all elements can be broadly grouped into two categories: metals and nonmetals. And this classification starts with something very basic: physical properties. Metals are typically shiny, flexible, and excellent conductors of heat and electricity. Nonmetals, in contrast, are dull-looking, brittle when solid, and poor conductors. For example, copper is used in electrical wiring because it conducts electricity very well, while sulfur is used in matchsticks due to its reactive nature, despite being brittle. But here's the twist: some elements blur the line, showing us that physical properties alone aren't always enough to categorize an element definitively. Let's look closely at how metals and nonmetals behave when we observe or handle them. Start with metallic luster. Freshly polished copper or aluminium has a characteristic shine that's called metallic luster. Now take hardness. Most metals are hard, but not all. Iron is clearly hard, but sodium and potassium? You can literally cut them with a knife. This softness is why we need to be cautious while handling alkali metals. Malleability is another important property. It's the ability to be hammered into thin sheets. Gold and silver are the most malleable, that's why gold leaf is so thin yet strong. In contrast, nonmetals like iodine or sulfur crumble instead of flattening. That's why you won't find nonmetals being used for structural parts. Now let's stretch our understanding literally. Ductility refers to the ability to draw a substance into wires. And gold takes the crown here. You can draw a wire 2 kilometers long from just 1 gram of gold. Next is conductivity. Metals like silver and copper are the best conductors of heat and electricity. That's why copper is used in electrical wires and silver in high precision circuits. But here's an exception you should remember: graphite. Even though it's a nonmetal, graphite conducts electricity due to its free electrons. On the other hand, nonmetals like sulfur or phosphorus are insulators. Also, remember, not all metals conduct heat equally. Silver is an excellent heat conductor, while lead and mercury are poor in comparison. Have you ever seen a bell made of rubber or plastic? Probably not, because they won't ring. Metals are sonorous, they produce ringing sounds when struck, and that's why school bells and gongs are made of metals like bronze. Let's talk about melting points. Most metals have high melting points, think iron or tungsten. But here come the exceptions again. Gallium and cesium are metals that melt in the warmth of your hand. Nonmetals, in general, have lower melting points, but graphite once again is an exception. It has an extremely high melting point due to its strong covalent bonding. That's why it's used in crucibles. So, both heat and sound behavior tell us a lot about what an element is and what it isn't. Let's wrap up with the rebels, the exceptions that challenge our definitions. Take iodine, a nonmetal that's shiny. Or graphite, again a nonmetal that conducts electricity and withstands heat. Then there are alkali metals like lithium and potassium, soft enough to slice and light enough to float on water. Diamond, on the other hand, is a form of carbon, a nonmetal, but it is the hardest known natural substance on Earth. These anomalies tell us one thing: while physical properties are extremely useful in classifying elements, nature always surprises us. That's why we need a mix of physical and chemical properties to make meaningful classifications in the periodic table.